from GATE 2019 Instrumentation and Process Control for 2 marks. The question is, choose the option that correctly matches the step responses curve on the left with the appropriate transfer function on the right. The step input change occurs at time t is equal to 0. So let's start with the solution with the first. We will take first transfer function. So you can see here it is our first transfer function, gs is equal to k zeta s plus 1 s into tau s plus 1. You can see here there is zeros and poles also, and first we will check there is positive zeros or not. Since we can see here there is a one inverse response here, this is the inverse response, so we will check for this. You can see here you know that whenever we calculate the poles we will put denominator is 0, and when we want to calculate the zeros then we will put numerator is equal to 0. So if we put numerator is equal to 0, then you can see here we will get s is equal to 1 minus 1 upon zeta. This is a negative 0. Since you can see here zeta is greater than 0, so it is negative 0. So this option will not match with this, since there is no inverse response. Whenever there is an inverse response, it is a there should be a positive zeros, right? So we will check it further. You know that we can write it as ys upon xs is equal to k zeta s plus 1 upon s into tau s plus 1. Since it is given that we will check for step response curve, step response, so we will give it a step response. So you can see here ys is equal to 1 upon s, we can write it as, it will be sys k zeta k into zeta s plus 1 upon s into this. So we will use two theorems, initial value theorems. S tends to infinity, you know that whenever we use initial value theorem, t tends to 0 and s tends to infinity. And if you see here, if we apply this, you will get s tends to, whenever there is s tends to infinity, then sys is 0. This term will be 0, since you can see here there is a 1s here. If you take s common from the numerator, s common from the denominator, s to s will be cancelled out, it will be zeta plus 1 upon s. It will be this, but there is a 1s also present here, so it will give you 0. Initial value theorem. And final value theorem, s tends to 0, it will give you infinity. So you can see here from the graph, initial 0, we have three options here. Initially it is 0, it is also 0, and it is also 0. You can see here this step response, you can see here it is constant after very long time, but this is increasing continuously. As time goes, it will increase further, it will go to infinity also. So first will satisfy with q, first will be q, right? So we will check other transfer function also, we will use this again. So we will check it for inverse response first. You can see here zeta s plus 1 is equal to 0, again s is equal to minus 1 upon zeta, and you can see here zeta is greater than again 0, so it will be negative 0. You can see here it will give you negative 0. So this is not satisfy that inverse response, so we will check it further. Again we get sys is equal to this, since we are giving the step response. From this we will use two theorems again, then you can apply this. We will take s common, then it will give us k zeta plus 1 upon s, and if we put s is equal to infinity, then it will give 0, and it is 0, and we get k zeta upon tau, right? This is k zeta upon tau. We will apply again final value theorem. If s tends to 0, that means t tends to infinity, sys is equal to k zeta s, and if we put s is equal to 0, then we get k. So first we are getting initially k zeta upon tau, that is non-zero, and sys is equal to k in final condition, means t tends to infinity. So you can see here from the graph, you can see here k zeta. If you see here, k is common in both, but there is a multiplication of zeta by tau. If you see here, for this option, right, zeta is greater than tau, right? If zeta is greater than tau, that means zeta upon tau will be greater than 1, and greater than 1, if we multiply k with the greater than 1, then it will be more than k, right? So this will satisfy S, since initial value is higher and finally it will go with k. It will, as t increases, and it will go final steady state will be k, right? Since at t tends to infinity and s tends to 0, we are getting k, right? So second will match with S. Now third, you can see here there is no zeros, k upon tau s plus 1, and automatically it will not match with this R. So we will check it. What is this? Actually it is a first order transfer function. If you know the response of first order transfer function, you can directly say it is P, but we will check it. What will happen if we use this theorem? Again SYS will be this, right? You can see here SYS is equal to this initial value theorem. If we apply, then we see here it will be infinity, then it will give you 0, and final value we get k. You can see here from the graph, again you can see here initially we are getting 0, and after that we are getting value k. Final steady state is k. Finally we are matching first, second and third, right? And definitely we can say first is matching with q, second is matching with S, and third is matching with P. So automatically it will be this, but we will check it how it can be. You can see here zeta s plus 1 is equal to 0. If we want to calculate the zeros, zeta s plus 1 is equal to this, then we will get again s is equal to minus 1 upon zeta, and here it is given that zeta is less than 0. If zeta is less than 0, it will automatically be positive, so we are getting 1 positive 0. So automatically this is the inverse response, so we will get R should be fourth, right? And if you want to check it further, initial value theorem and final value theorem, you can see here, if we apply, you can see here I have already written as zeta is, they have given zeta is less than 0, it will be positive. And you can see here if we use this initial value theorem, we will get SYS is equal to 0. Since we are taking s tends to infinity, then as it will be 0. And if final value theorem, if I apply, you can see here if I put s is equal to 0 in this, s is equal to 0, then I got finally k. And you can see here from the graph it is going like this. Final steady state is k only, right? It is not increasing further. So option B is correct. Option B is correct. So thank you. Please make sure to like, share and subscribe my channel. Thank you.